from the U.S. Energy Information Administration. Gasoline explained. Basics. Gasoline is a petroleum product. Gasoline is a fuel made from crude oil and other petroleum liquids. Gasoline is mainly used in vehicle engines. Petroleum refineries and blending facilities produced finished motor gasoline for retail sale at gasoline fueling stations. Pausing the reading to go to the glossary. Motor gasoline finished. A complex mixture of relatively volatile hydrocarbons with or without small quantities of additives, blended to form a fuel suitable for use in spark ignition engines. Motor gasoline, as defined in ASTM specification D4814 or Federal Specification BV-G-1690C, is characterized as having a boiling range of 122 to 158 degrees Fahrenheit at the 10% recovery point to 365 to 374 degrees Fahrenheit at the 90% recovery point. Motor gasoline includes conventional gasoline, all types of oxygenated gasoline, including gasohol and reformulated gasoline, but excludes aviation gasoline. Note: volumetric data on blending components such as oxygenates are not counted in data on finished motor gasoline until the blending components are blended into the gasoline. Next, motor gasoline blending. Mechanical mixing of motor gasoline blending components and oxygenates when required to produce finished motor gasoline. Finished motor gasoline may be further mixed with other motor gasoline blending components or oxygenates, resulting in increased volumes of finished motor gasoline and or changes in the formulation of finished motor gasoline. Example: conventional motor gasoline mixed with MTBE to produce oxygenated motor gasoline. Next, motor gasoline blending components. Naphtha. Example: straight run gasoline, alkylate, reformate, benzene, toluene, xylene, used for blending or compounding into finished motor gasoline. These components include reformulated gasoline blend stock for oxygenate blending, RBOB, but exclude oxygenates, alcohols, ethers, butane, and pentanes plus. Note: oxygenates are reported as individual components and are included in the total for other hydrocarbons, hydrogens, and oxygenates. Resuming the main reading. Most of the gasoline petroleum that refineries produce is actually unfinished gasoline, or gasoline blend stocks. Gasoline blend stocks, finished gasoline, and fuel ethanol are blended to make finished motor gasoline in different grades and formulas at blending terminals. Some companies also blend detergents and other additives with their gasoline before delivering to their retail outlets. Blending terminals are more numerous and widely dispersed than petroleum refineries, and they have equipment for filling tanker trucks that transport finished motor gasoline to retail outlets. Most of the finished motor gasoline sold in the United States contains about 10% fuel ethanol by volume. Ethanol is added to gasoline mainly to meet the requirements of the Renewable Fuel Standard, which is intended to reduce greenhouse gas emissions and the amount of oil in the United States imports from other countries. Gasoline varies by grade. 3 main grades of gasoline are sold at retail gasoline fueling stations: regular, mid-grade, premium. Some companies have different names for these grades of gasoline, such as regular, unleaded, mid-grade, medium, super, premium, or super premium, which all indicate the octane rating, the anti-knock property of gasoline. No grade of motor gasoline now sold in the U.S. contains lead. The lowest octane rating gasoline is usually the least expensive. Vehicle manufacturers recommend the grade of gasoline each model of their vehicle should use. Pausing the reading to go to the glossary. Never mind, it's not a glossary link, but I will continue. Gasoline also varies by formulation. In addition to the grade of motor gasoline, the formulation of gasoline may differ depending on the location where it is sold and the season of the year. Federal and state air pollution control programs that aim to reduce carbon monoxide, smog, and air toxins require oxygenated, reformulated, and low volatility gasoline. Some areas of the country are required to use specifically formulated gasoline to reduce certain emissions, and the formulation may change during winter and summer months. These area-specific requirements mean that gasoline is not the same everywhere. Gasoline produced for sale in one area of the United States might not be authorized for sale in another. Now I will read the Did You Know section. Gasoline changes with the seasons. The main difference between winter and summer grade gasoline is vapor pressure. Gasoline vapor pressure is important for an automobile engine to work properly. During winter months, vapor pressure must be high enough for the engine to start easily. In the summer, lower vapor pressure is required in many areas to reduce air pollution. Gasoline evaporates more easily in warm weather, releasing more volatile organic compounds that contribute to health problems and to ground level ozone and smog. To cut down on pollution, the U.S. Environmental Protection Agency requires petroleum refiners to reduce the vapor pressure of gasoline during the summer. The characteristics of gasoline depend on the type of crude oil used to produce it and the setup of the refinery that produces it. Gasoline characteristics are also affected by other ingredients that may be included in the blend, such as ethanol. Moving on to the next section, octane in depth. What is octane? In recent years, car manufacturers have been requiring or recommending premium gasoline, a high-octane fuel, for more of their vehicle models. The price difference between premium and lower octane grades has also increased. The octane rating is the measure of fuel stability. The rating is based on the pressure at which fuel spontaneously combusts, auto-ignite, in a testing engine. The octane number is the simple average of two different octane rating methods: motor octane rating, MOR, and research octane rating, RON, that differ primarily in the specifics of the motor operating conditions. The higher an octane number, the more stable the fuel. Retail gasoline stations in the United States sell 3 grades of gasoline based on the octane level. Regular, lowest octane fuel, generally 87. Mid-grade, the middle range octane fuel, generally 89 to 90. Premium, the highest octane fuel, generally 91 to 94. Some companies have different names for these grades, such as unleaded, super, or super premium, but they all refer to the octane rating. A gasoline pump showing different grades of gasoline and octane ratings. Disregard that, because this will be an audio-only file for YouTube and other social media. Reading the Did You Know section. The large number on the yellow gasoline pump octane label is the minimum octane rating, R plus M divided by 2. Method on the label refers to the octane testing method used, where R is research octane number and M is motor octane number. Resuming the main reading. Of the 18 isomers of normal octane, C8H18, octane gets its name from the 2,2,4-trimethylpentane compound, which is highly resistant to autoignition. This isooctane has been assigned the reference value of 100 for testing purposes. The extremely unstable normal heptane, C7H16, molecule is the zero-octane reference fuel. How does the octane level affect my vehicle? Engines are designed to burn fuel in a controlled combustion. A flame starts at the spark plug and burns throughout the cylinder until all fuel in the cylinder is burned. In comparison, spontaneous combustion, also called auto-ignition, detonation, or knock, happens when rising temperature and pressure from the primary combustion causes unburned fuel to ignite. This uncontrolled secondary combustion causes pressure in the cylinder to spike and causes the knock to occur. The competition between the intended, controlled, and unintended, spontaneous, combustion causes the energy from the burning fuel to disperse unevenly, which can damage and place high pressure on the engine's pistons before it enters the power stroke, the part of the cycle when the piston's motion is generating power. Before electric computerized ignition was widely used, this knocking commonly occurred and could cause significant engine damage. Most modern engines have sensors to detect knocking. When detected, the computer delays the initial spark, which causes the controlled combustion to take place at a point when compression is not at its highest. Although this eliminates the knock, it can cause the engine to run less efficiently. A similar undesirable condition is called pre-ignition, when the fuel ignites on its own before the spark ignites it. Modern engine computers minimize this condition by controlling the timing of valves and fuel injection. However, this control mechanism can also come with a fuel efficiency or emissions penalty. How is octane measured? The standard means of testing octane is with an octane testing engine. This test is similar to the way an object's mass can be determined by comparing it to objects, references of known mass on a balanced scale. Primary reference fuels, PRF, of precisely known octane are formed by combining isooctane, heptane, and other well-known standards, such as toluene. These PRFs are used to bracket a given fuel sample to determine the pressure at which similar knock intensities are observed. This measurement is taken by adjusting the octane engine's cylinder height, which changes the compression ratio/pressure in the engine until the knocking reaches a specific intensity level. The R plus M divided by 2 you see on the label refers to the average of the research octane number, RON, and the motor octane number, MON. To determine the RON, the fuel is tested under engine ideal conditions with a low air temperature and slow engine speed. To determine the MON, the fuel is tested under the more stressful conditions of higher air temperature and engine speed. Historically, RON and MON were determined on separate testing machines specifically configured for each test. Current designs allow the same engine to perform both tests. Despite this flexibility, many testers still prefer to use more than one machine, with each specifically set up and calibrated to perform either RON or MON tests. On to the next section, where our gasoline comes from. Basics. Determining the source of the gasoline you purchase. The exact origin of gasoline sold at fueling stations cannot be determined because of the stages and processes involved in producing gasoline and delivering it to retail fueling stations. Acquiring crude oil. U.S. petroleum refineries make gasoline and other petroleum products from crude oil and other liquids that are produced in the United States or imported from other countries. The specific sources of the crude oil and other liquids used at refineries may vary. Most U.S. refineries use a mix of crude oils from various domestic and foreign sources. The mix of crude oils can change based on the relative cost and availability from those sources. Refining oil into gasoline. At petroleum refineries, crude oil is broken into its various components, which are then made into new products. U.S. refineries generally focus on producing gasoline to meet U.S. market demand, and they produce nearly all gasoline sold in the United States. Moving gasoline from refineries to storage terminals. Most gasoline moves from refineries through pipelines to large storage terminals near consuming areas. Gasoline and other petroleum products from different refineries are often sent through shared pipelines in batches. These batches are not physically separated in pipelines, and some mixing or commingling of products occur. Co-mingling of products occur. Because of this mixing, the gasoline and other products must be tested as they leave pipelines to see if they meet the required specifications. If a product fails to meet local, state, or federal specifications, it is sent back to a refinery for additional processing. Finishing gasoline at blending terminals. Gasoline is usually sent by tanker truck from large storage terminals to smaller blending terminals, where it is processed into finished motor gasoline. These smaller terminals are typically where fuel ethanol is blended into gasoline. Importing gasoline. The United States imports both finished motor gasoline and gasoline blending components from various countries, mainly into the east and west coasts, when it is less expensive or faster to obtain from other countries than from domestic suppliers. Delivering gasoline to fueling stations. Tanker trucks deliver the finished motor gasoline from blending terminals to more than 100,000 retail outlets across the United States. Different companies that own service stations in the same area may purchase their gasoline at the same bulk storage and distribution terminal. Many of the stations are unbranded dealers that sell gasoline produced by different companies, and branded stations may not necessarily sell the gasoline their companies produce. The only difference between the gasoline at one company's fueling stations and another company's stations is the small amount of additives they might blend into the gasoline before delivery to their fueling stations. Use of gasoline. Next section. Basics. Gasoline is the primary U.S. transportation fuel. In 2025, Americans used about 136.72 billion gallons of gasoline, including 136.53 billion gallons of finished motor gasoline, about 374.05 million gallons per day, and about 0.19 billion gallons of finished aviation gasoline. Motor gasoline is one of the most consumed fuels in the United States and the main product that U.S. oil refineries produce. Most of the finished motor gasoline sold for vehicles in the United States is about 10% fuel ethanol by volume. U.S. consumers use gasoline in cars, sports utility vehicles, light trucks, and motorcycles, recreational vehicles, and boats. small aircraft, equipment and tools used in construction, farming, forestry, and landscaping. Electricity generators for portable and emergency power supply. In 2025, total gasoline consumption, based on energy content, accounted for about 56% of total energy consumption in the transportation sector and 16% of total U.S. energy consumption, and based on volume, 46% of total petroleum consumption. Footnote 1. Light-duty vehicles, cars, sports utility vehicles, and small trucks account for about 91% of all gasoline consumption in the United States. Footnote 2. Pausing the reading to read the footnotes. Footnote 1. Total gasoline includes finished aviation gasoline and finished motor gasoline, including fuel ethanol. Data source, Monthly Energy Review, March 2026. Footnote 2. Estimates are from the Annual Energy Outlook, 2026. Counterfactual baseline case. Table 36. April 2026. Resuming the reading. Texas and California consume the most gasoline. Gasoline use varies among the states, but Texas and California have historically accounted for the largest shares of total U.S. motor gasoline consumption. So there is a table, and I will describe it. It is divided into 4 sections: state, million barrels per day, million gallons per day, and percentage of total U.S. gasoline consumption. First state is Texas, consumes 0.92 million barrels per day, which is also 38.55 million gallons per day. And its percentage of total U.S. gasoline consumption is 11%. Next is California, at 0.79 million barrels per day, or 33.31 million gallons per day, and it's at 9% of total U.S. gasoline consumption. Next state is Florida, at 0.49 million barrels per day, which is 20.62 million gallons per day, and it accounts for 6% of total U.S. gasoline consumption. New York is at 0.33 million barrels per day, which is 14.01 million gallons per day, and it is at 4% of total U.S. gasoline consumption. And lastly is Georgia, which is said to consume 0.32 million barrels per day, or 13.65 million gallons per day, and it is at 4% of the total U.S. gasoline consumption. So this table is titled The Top 5 Total Gasoline Consuming States, 2021, and the data source is the U.S. Energy Information Administration, Petroleum and Other Liquids, Prime Supplier Sales Volume, as of June 8, 2022. Note, the Prime Supplier report has been suspended. Moving on to the next section. Gasoline prices and outlook. How do recent gasoline prices compare with historical prices? 2 ways to compare current gasoline prices with historical prices are by the nominal price or the real price. The graph below shows the average annual, nominal, and real prices of retail regular grade gasoline from 1976 through 2027. The real prices are based on the value of the US dollar in February 2026. The graph also shows the U.S. Energy Information Administration, EIA, forecast for average annual prices for 2026 and 2027 in the February 2026 short-term energy outlook. And I'm just going to make this an audio, so I will just describe it. 1976, the real price was $3.52 per gallon. Nominal price was 61 cents per gallon. In 1980, the real price was $4.93 per gallon. The nominal price was $1.25 per gallon. In 1985, the real price was $3.54 per gallon. Nominal price was $1.17 per gallon. In 1990, the real price was $2.82 per gallon. The nominal price was $1.13 per gallon. In 1998, the real price was $2.06 per gallon. The nominal price was $1.03 per gallon. In 2008, the real price was $4.94 per gallon, and the nominal price was $3.26 per gallon. But in the following year, 2009, the real price was $3.57 per gallon, and the nominal price was $2.35 per gallon. In 2012, the real price was $5.16 per gallon. The nominal price was $3.63 per gallon. In 2016, $2.92 per gallon was the real price. Nominal price was $2.15 per gallon. 2018, real price $3.54 per gallon. Nominal price $2.73 per gallon. 2020, real price $2.75 per gallon. Nominal price $2.18 per gallon. 2022, real price $4.43 per gallon. Nominal price $3.97 per gallon. And last one I'll do is 2026. Real price $2.89 per gallon. Nominal price $2.91 per gallon. And I'm assuming that is before the U.S. and Israel war with Iran, which, just take a brief moment. So according to Wikipedia and then looks like Gemini AI overview, I'm not going to go too deep, just, New York Times as well. The date is February 28, 2026. So, yeah, definitely. Since the prices that I just read are not indicative of today, which is April 28th, 2026. Before I resume the reading and read the source, I will just check let's see. Also from the U.S. Energy Information Administration, in the category Petroleum and Other Liquids, Gasoline and Diesel Fuel Update. Gasoline release date April 28th, 2026. U.S. regular gasoline prices, dollars per gallon. I will read just for April 27th, which was yesterday. U.S. $4.12 per gallon. And even though this is the gasoline series that I'm reading, I'm going to just jump down to on-highway diesel fuel price for April 27, 2026. In the U.S., it is $5.35 per gallon. So I will exit this now and resume. So for the numbers from the line graph that I just read from, the data source is U.S. Energy Information Administration, Short-Term Energy Outlook, February 2026. Note, prices are retail prices, including taxes. Real prices are based on February 2026 dollar value. Of course, as I mentioned before the U.S.-Israel war with Iran started, which occurred right at the end of the month. Prices for 2026 and 2027 were forecasts, since, wasn't even going to bother reading 2027 because of the war. That forecast is going to be different. EIA publications that provide historical, recent, and projected U.S. retail gasoline prices, including federal, state, and local taxes, include Gasoline and Diesel Fuel Update. This weekly report provides the most recent available and historical nominal prices for retail gasoline, nationally and by PADD region. Gasoline prices from the report are available by grade and formulation and by area. Short-Term Energy Outlook, SDEO. This monthly report includes forecasts for average monthly, quarterly, and annual U.S. retail regular grade gasoline prices for the current year and for the next 1 to 2 years. The STEO Real Prices Viewer shows historical and forecast nominal and real prices for retail regular grade gasoline. Annual Energy Outlook, AEO. This report includes projections for average real and nominal prices for U.S. retail gasoline out to the year 2050. You can find these projections in the counterfactual baseline case, Table 12, Petroleum and Other Liquids Prices, and in the side cases. Moving on to the next section. Factors affecting gasoline prices. Gasoline types. Gasoline is sold based on octane levels in 3 primary grades of gasoline: regular, mid-grade, premium. The octane level indicates gasoline's resistance to combustion. Gasoline with a higher octane is less prone to preignition and detonation. also known as engine knocking. Refiners charge more for higher octane fuel, and premium grade gasoline is the most expensive. From 1995 through 2006, the price difference among grades of gasoline was typically about 10 cents per gallon. Since 2006, the price difference among gasoline grades has generally increased. In 2025, the national annual average price of mid-grade gasoline was about 57 cents per gallon more than regular grade gasoline. And the average price for premium grade gasoline was about 93 cents per gallon more than regular grade gasoline. Gasoline retail prices. The retail price of gasoline includes the cost of crude oil, taxes, refining costs and profits, distribution and marketing. What do we pay per gallon of retail regular grade gasoline? So this is a diagram. On the left, it shows the years 2016 to 2025. Average retail price, $2.89 per gallon. On the top, you have yellow, and it's marked at 15%, 15.0%. And it is classified as refining costs and profits. The next is 15.9%, and it's classified as distribution and marketing. The next is 17.4%, and it is color-coded as a dark orange, and it says federal and state taxes. Lastly, you have 51.7%, which is color-coded in blue, and it stands for crude oil. So on the other part of the image, you have a very similar setup, but the percentages are different. For refining costs and profit, it's 14.3%. And before I get into that, this is also for the year 2025, but the average retail price says $3.10 per gallon. So after that, you have distribution and marketing at 17.8%. Next, federal and state taxes, 16.6%. Lastly, you have crude oil at 51.4%. And the data source is the U.S. Energy Information Administration. Gasoline and diesel fuel update. Now, prices are nominal prices. The prices paid at the time of purchase. Retail pump prices reflect these components and the profits and losses of refiners, marketers, distributors, and retail station owners. The cost of crude oil. The largest component of the retail price of gasoline is the cost of crude oil, and its share of the retail gasoline price varies over time and across regions of the country. Many factors influence crude oil prices. In the past several years, higher U.S. oil production has helped to slow the rise of oil and gasoline prices. Gasoline taxes. Federal, state, and local government taxes also contribute to the retail price of gasoline. The federal tax on motor gasoline is 18.40 cents per gallon, which includes an excise tax of 18.30 cents per gallon, and the federal leaking underground storage tank fee of 0.1 cent per gallon. As of January 2026, state taxes and fees on gasoline averaged 33.55 cents per gallon. State taxes, along with local and municipal government taxes, may have a large effect on the retail price of gasoline in some locations. Refining costs and profits. Refining costs and profits vary seasonally and by region in the United States because different gasoline formulations are required to reduce air pollution in different parts of the country. The characteristics of the gasoline produced depend on the type of crude oil that is used and the type of processing technology available at the refinery where it is produced. Gasoline prices are also affected by the cost of other ingredients that may be blended into the gasoline, including fuel ethanol. Gasoline demand usually increases in the summer, which generally results in higher prices. Distribution and marketing. Distribution, marketing, and retail dealer costs and profits are also included in the retail price of gasoline. Most gasoline is shipped from refineries by pipeline to terminals near consuming areas, where it may be blended with other products, such as fuel ethanol, to meet local government and market specifications. Tanker trucks deliver gasoline to individual gasoline stations. Some retail outlets are owned and operated by refiners, and others are independent businesses that purchase gasoline from refiners and marketers for resale to the public. The price at the pump also reflects local market conditions and factors, such as the fueling location and the marketing strategy of the owner. The cost of doing business by individual gasoline retailers can vary greatly depending on where a gasoline fueling station is located. These costs include wages and salaries, benefits, equipment, lease or rent payments, insurance, overhead, and state and local fees. Even retail stations close to each other can have different traffic patterns. Rent and sources of supply that affect their prices. The number and location of local competitors can also affect prices.